Our video today is going to deal with the real numbers section. This is the overall encompassing part of the whole year for what you're going to do in here. Everything that we do can lead back to real numbers and the terms that we're going to go through. And that's what we're going to do right now, is just take care of some vocabulary. So we're going to start with real numbers. They're positive or negative. They can be large or small. They can also be whole numbers, decimal numbers, and also fractions. So some of the more specific ones are natural and counting numbers. These are numbers that just start with 1, 2, 3, 4, and keep going. So it's just what we use to count things. There's no negatives and there's no fractions involved with it. For a whole number, we just simply put a 0 in front of it and we start counting with the counting or natural numbers. So again, 0, 1, 2, 3, 4. There are no fractions, there are no decimals, and there's no negatives in this. Integer, no fractional part, so there's not a setup that looks like this. It includes counting numbers, whole numbers, but it's now bringing in the negatives of those, so the opposites of those as well. So we have a -3, a -2, a -1. We have our 0, and then we have 1, 2, and 3. So here's the positives, here are the negatives. Those are all referred to as integers. Rational, any number that can be expressed as a quotient, which is division, or fraction, which also shows division. That little line there tells us division of two integers. So they could be positive or negative, or both, with the denominator b not equal to 0. You can never have a 0 at the denominator spot of your fraction. Since b can be 1 though, every integer is a rational number. A couple more. Irrational. Any real number that cannot be expressed as a ratio of integers. Another word for ratio is fractions. So irrationals are kind of the crazy numbers, the ones that we won't really work with, but you have to be able to identify them. They cannot be represented by simple fractions. They are not terminating, meaning they stop, decimals, or repeating decimals, which are the ones that you put the little line over the top to show that that part of it is a repeating pattern for this. So they're not terminating, not a repeater, and they don't have a pattern that takes place. Those are irrational numbers. Now what we're going to do is work with what are called subsets. And subsets is basically a set that is inside another set. So you have to be inside for a subset to be a subset. It can't be an outside. That's what we call a superset, but we can't be anywhere else. So in my diagram here, A is a subset of C because A is inside C. So A is a subset of this. So as we start in, as you work out, everything that this is inside is a subset. So as you keep that in mind, here's how we're going to put this all together. This is how it fits. So we're going to start small and work our way big. So our first circle is natural counting numbers. 1, 2, 3, 4, so forth. That starts on the inside. This is a subset of whole numbers because it's inside the whole number section. So this would be the A, this would be the C if you go back to the definition of subsets that I gave you. So we have 0, 1, 2, 3, 4. So natural numbers are a subset of whole numbers. Whole numbers are not a subset of natural numbers. Natural numbers are a subset of whole numbers. Whole numbers are a subset of integers. So we're working our way out. So these are subsets of this. This is not a subset of this. This is not a subset of this. This can be said as a subset of an integer, but it's also whole numbers, so you want to include all of the stuff that they're a part of as that subset. Getting bigger. Natural counting numbers are a subset of whole numbers, which are a subset of integers. All three of these are a subset of rational numbers. So rational numbers are fractions, can be negative, repeating decimals, have a pattern, terminating decimals, they stop. Proper fractions, mixed numbers, they can also be negative like I showed you here. Big picture. All of this is a subset of this. So this is a subset of this. 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 Irrationals aren't a subset of any of this. The only thing they are a subset of are real numbers. That's the only thing that they're a part of. This is not a subset if you're going this way. If you're starting here or here and you're working this way, it's a subset. This cannot be a subset. This cannot be a subset. This can be a subset. Hope you got all that movement. That's why you can pause and rewind. So how does this work in questioning? Well, here's what you're going to get. Here is kind of a code that we're going to use in class. It'll be on your worksheets. It'll be on your assignments. You can see that. So some of the examples. Which number set does these belong to? The square root of 2 is an irrational number. It is a number that if you threw into a calculator, it would not stop. Your calculator would make it stop because it doesn't have that long of a screen. It'd keep going. There is absolutely no pattern in that. There's no repeating in it. So this is a irrational number. Negative 0.2 repeating. This could be a part of an integer. It can be a part of a rational number, and it's a part of the real numbers. 5 could be a natural counting number, could be a whole number, could be an integer, could be a rational number, could be a real number. Negative 15, look what it is. It's an integer. So we'd start at integer. So it's an integer, which is also a subset of rational, which is also a subset of real numbers. So it would belong to those three. So you want to find the smallest, and everything above that is going to be a part of the answer. So which set below is a subset of the second set? So if I go back to my code here, I have Wn. Well, is a whole number a part of a natural number? Well, if you look at my diagram down here, I start at whole and I go this way. Look at the direction that my finger's going on this. Think of these two words. Z, I. Z is integers, I is irrational. We're going to start at integers, we're going to go to irrationals. If you cross that line, it can't be a subset. So there's no subset there. So these two are not a subset. I, Q. I is irrational, Q is rational. Irrational to rational cannot be a subset. These two cannot work together. The only thing this works with is real numbers. That's it. That's it. Last one. RZ. R is real numbers. Z, integers. Real to integers, it's not a subset. It'd be a super subset or a superset, but it wouldn't be a subset. So none of these worked out to be a subset. So if you're going from the first letter or the identification of that, that's where you start. If you go up in the chart, if you want to do this, or if I bring back this one, if you start on the inside and work your way out, it works. If you're going from here, if you're starting at the top and working down, does it work? That's the easy way to remember this. If you draw a drawing like this or a diagram. I can also use it as an example of this. I have a big bowl. The big bowl represents real numbers. Inside of there, I have irrational, rational. The only thing that this is a subset of is the real number, so it would fit in the bowl. Inside my rational numbers, I have integers. Inside of the integers, I have my whole numbers. Inside my whole numbers, I have my natural and counting numbers. So if you think of it as a glass set, natural and counting are a subset of whole numbers. Whole numbers can't fit, won't fit in there. It cannot be a subset of it. So it works natural to counting to whole. That is an integer. All of this is a rational number, which all fits in real numbers. There is your examples. Use your notes. Take your notes wisely. Work on your assignments. Good luck.